Hello students, welcome to our channel Math with Gigi. This video is part 2 of how to find YP using general method. If you have not watched part 1, please go in the description, watch the part 1 and then come back to this part 2 of how to find YP using general method. In this video, we'll discuss 2 more examples of finding YP using general method. Let's start with the video. First, the example is d square plus d into y equal to sec square into 1 plus 2 tan x. As you observe f of x, it is not of neither of the type 1 to 6 of shortcut method. Hence, we have to apply general method to solve this. So, the formula for YP is 1 upon phi of d f of x, that is equal to 1 upon d square plus d into sec square x into 1 plus 2 tan x. Now, we have to factorize the denominator. Now, the factorization is very easy. You can take d common. So, 1 upon d into d plus 1 sec square x into 1 plus 2 tan x. Now, we have to do partial fraction of this 1 upon d into d plus 1. So, let's call this as equation number 1. Consider 1 upon d into d plus 1 equal to a upon d plus b upon d plus 1. Cross multiplying the term and cancelling the denominator, we get a into d plus 1 plus b into d equal to 1. We have to put the value of d such that one of the coefficient is 0. So here, if we put d equal to 0, we get a into 1 plus b into 0 equal to 1, that is a equal to 1. Similarly, if we put d equal to minus 1, we get a into 0 plus b into minus 1 equal to 1, that is b is equal to minus 1. Now let's substitute these values in equation number 1 and in this equation. Therefore, we get p 2. Now a is 1, so 1 upon d. B is minus upon into sec square x into 1 plus 2 tan x. So, we have simply substituted the value of a and b in this equation and back substituted in equation number 1. So, we get this. Now, multiply the term to both. So, 1 upon t sec square x into 1 plus 2 tan x minus d plus 1 sec square x into 1 plus tan x. Now, we'll consider the formula for general methods. Now, if you observe the second term, it is 1 upon d plus 1. So, we have to use the formula 1 upon d plus a f of x equal to e raised to minus x integration e raised to ax f of x dx. Whereas, if we are having only d, now what is d? D is the operator derivative. Hence, if 1 upon d is there, it is integration. The inverse operator of derivative, that is integration. So, we can write this integration 1 plus 2 tan x dx minus, using the formula of general method, e raised to minus x integration e raised to x sec square x into 1 plus 2 tan x dx. Let us call this as equation number 2. Now, we will calculate this integration separately. So, we will consider the first integration as I1, second integration as I2, and we'll back substitute the values of both integrations in equation number 2 to get the final answer. Now, let's consider the first integration as I1 and second integration as I2. These two integration cannot be solved directly. So we'll consider them separately and we first calculate them and back substitute in equation number 2. So let I1 is equal to integration sec square x into 1 plus 2 tan x dx. Now if you observe this integration, the derivative of tan x is sec square x, which is already present over there. So this integration can be solved using substitution. So put tan x equal to t. Therefore, sec square x dx equal to dt. Therefore, I1 is equal to. Now, if you observe this sec square x and dx, this term we will replace by dt. So, integration is sec square x into dx is dt into 1 plus 2t because tan x is t. Now, if you integrate this term, the integration of 1 is t plus integration of 2t is 2t square by 2. 2 get cancelled. So we get t plus t square. Back substituting the value of t as tan x, I1 is equal to tan x plus tan square x. Now we solve second integration. Let I2 is equal to integration e raised to x sec square x into 1 plus 2 tan x dx. Now let's multiply this sec square x inside the bracket. So we get integration e raised to x into sec square x plus 2 tan x sec square x into x. Now there is one formula of integration. Let's recall that formula. Integration e raised to x f of x plus f dash of x dx. E raised to x into f of x plus f dash of x dx is equal to e raised to x f of x. Now if we search this term, the term we call it sec square as f of x. So what is the derivative of sec square x? It is something square. So derivative of sec square x will be 2 into sec x into derivative of sec x is sec x tan x. So if we call f of x as sec square x, therefore f dash of x will be 2 sec, derivative of sec square x is 2 sec x into f sec x, sec x. So that is nothing but 2 tan x in sec square x. That is the second term. So clearly it is of the form e raised to x f of x plus f dash of x. So if you apply this formula, we get I2 is equal to e raised to x into f of x is sec square x. So the first integration is tan x plus tan square x. Second integration is e raised to x into sec square x. Let us substitute both the integrations in this equation number 2. So we get from 2 yp is equal to, now integration of the first term, that is I1 tan x plus tan square x minus e raised to minus x and the integration of I2, that is this term, e raised to x sec square x. Now e raised to x into e raised to minus x will get cancelled out. Therefore, the final answer is tan x plus tan square x minus sec square x. So this is the example number 2 for finding yp using general method. Now let's discuss another example of finding yp using general method. Example number 3, d square plus 3d plus 2 into y equal to sine e raised to x. Now if you observe again f of x, it is of the type sine, that is type number 2. But if you observe the angle, it is not the usual angle. Hence, we cannot use shortcut method to find yp for this example. So we have to use general method. So let's start with the solution. Equal to 1 upon phi of d f of x. So that is equal to 1 upon d square plus 3d plus 2 into sine e raised to x. Now factorize denominator. So the factors of d square plus 3d plus 2 are d plus 1 into d plus 2 sine e raised to x. Now let's call this the equation number. We have to find the partial fraction of this term. So 1 upon d plus 1 into d plus 2 equal to a upon d plus 1 plus b upon d plus 2. Cross multiplying and cancelling the denominator, we get a into d plus 2 plus b into d plus 1 equal to 1. Now put d equal to minus 1. Therefore, we get a into minus 1 plus 2 is 1 plus b into 0 equal to 1. So a equal to 1. Put d equal to minus 2. So we get a into 0 plus b into minus 1 equal to 1. Hence, b equal to minus 1. Now let's substitute this value in this equation and substitute the term in equation number 1. So we get yp is equal to 1 upon d plus 1 minus upon into sine e raised to x. Let's multiply sine e raised to x to both the terms. This is equal to 1 up to sine e raised to x. We have to use general method formulae for finding this term. So 1 upon d can be e raised to x integration e raised to x sine e raised to x dx minus e raised to minus 2x integration e raised to 2x sine e raised to x dx. Let us call this as equation number 2. Now, we will separately calculate both the integrations by considering I1 and I2, and by substituting in equation 2, we'll get the required yp. Now, let's calculate both the integrations and back substitute in equation number 2. Let I1 equal to integration e raised to x sine e raised to x dx. This integration cannot be solved directly, so we have to substitute e raised to x as t. So put e raised to x equal to t. Therefore, e raised to x dx equal to dt. Therefore, I1 is equal to integration. Now, if you observe the term e raised to x dx, it is replaced by dt, and sine e raised to x will be sine t. The integration of sine is minus cos. So, integration of sine t will be minus cos t. By substituting the value of t as e raised to x, so I1 is equal to minus cos e raised to x. Similarly, let I2 is equal to second term e raised integration e raised to 2x sine e raised to x dx. Again, if we substitute e raised to x, we will get the solution of this integration. Put e raised to x t. Therefore, e raised to x dx equal to dt. Therefore, I2 equal to. Now, if you observe the term e raised to 2x, it can be split into two parts, e raised to x into e raised to x, and one e raised to x dx can be replaced by dt, and one e raised to x will be replaced by t. Hence, we get I2 is equal to t sine t dt. If you observe, t is polynomial, so we will use the formula of integration pf. So, t as it is, integration sine t dt minus derivative of sine is 1, double integration of 2. So, t as it is, integration of sine is minus cos minus double integration or 2 times integration of sine will be integration of this bracket. So, integration of minus cos is minus sine t. So, simplifying the term, we get minus t cos t plus sine t. Now substitute the value of t. So we get I2 is equal to minus e raised to x cos e raised to x plus sin e raised to x. Substituting both the values in equation 2, so get yp equal to e raised to minus x as it is. The integration of this value is I1, that is minus cos e raised to x minus e raised to minus 2x as it is, into the integration of the second term is minus e raised to x cos e raised to x plus sin e raised to x. Now, the terms we get minus e raised to x cos e raised to x. Now, if you multiply this minus minus plus, and e raised to minus 2x into e raised to x will be e raised to minus x into cos e raised to x minus e raised to minus 2x into sin e raised to x. So this term get cancelled. So we get yp as minus e raised to minus 2x sin e raised to x. So this is the value of the integrations, and if you substitute this to, we get the required yp. So this video is about how to find yp using general method part 2. If you find this video useful, please like and share the video with your friends. If you have not subscribed our channel, subscribe our channel Math with Gigi for such informative videos. Thank you.